All right. Welcome to Math Made Easy. Today we are going to talk about the limit of a function. The limit of a function. So when we talk about the limit of a function, what does it mean? So basically, when we talk about the limit of a function, let's use this particular table here to define it. Now let's consider this function here. Let's consider this function here. We are having f of x being equal to x squared minus x plus 1. So considering this function for the values of x getting close to 2. So we're going to consider this function for the values of x. We have unknown here x. We are going to look at a series of values which are getting or approaching what? 2. Now from the table here, we have the function here, then we have the values of x. So we're going to look at it from the left hand side, then also from the right hand side. Now let's look at this function here. This function, what happens when the value of x is 1.0? We have this, so it means that when I have this, when I put 1 here, this is what I'm going to get. When I put 1.5, this is what I'm going to get. When I put um, 1.9, this is what I'm going to get. Now you realize that as we move down, as we move down, as the values of x increasing, are increasing, they are getting closer to a certain number. Now you can see that this number here, the last number here, is closer to what number? 2. So as we define from the first one here, I say that the values of x getting closer to 2. Now you realize that when this side, the x values are getting closer to 2, you can see that the values of the function is also getting closer to what? 3. So this number, you can see that it is getting closer to what? 3. It's not exactly 3, but it's getting, or it is approaching what? 3. All right. Now let's look at it from this side. What happens when the values of x, you see from this side is moving from the down or from the bottom to the top, right? From the bottom to the top. Now we have 3 here. When I put 3 into the function here, this is what I'm going to get. When I put 2.5, you see that this time around it is decreasing. So it is decreasing. As it's decreasing from 3 to a certain number, which is getting closer to 2 again, what happens to the functional value? Now, from here, you can see that when I put in these values, it is also, this function is also approaching what? 3. All right. So you can see that the limit of that function, the limit of the function. So from the table above, you can see that you can, or we can observe that when x is close to 2 on either side of 2, either from the negative side or the positive side, the function is close to 3. So you see that the function will be getting closer to 3. So from both sides, as it's increasing from this side, it is getting closer to 2, decreasing from this side, it's getting closer to 3. So this also goes getting closer to 3. So we express this saying that the limit of the function this as x approaches 2 is what? 3. So by notation, we write it as this, the limit of the function, you see, the limit of the function as x approaches what? 2 is what? 3. All right, so that is the simple definition of the limit of a function. All right, so let's look at a simple or other simple laws of what? Limit. Suppose that c is a constant and the limit of the function f of x as x approaches a and the limit of the function g of x as x approaches a exist, then the limit of a constant is the constant. So when I take the limit of, let's say, the limit of 2 as maybe x is getting closer to what? 3, um, it is going to give us the same constant. So the answer is the same constant. So that let's note that one. And also, if I have um, this here, the limit of f of x or the limit of x here, the function x as x approaches a, it is going to be what? A. So you substitute a into this, you get a. And the limit of a sum is the sum of the limit. All right, so these two limits here, if I take the limit of, let's say um the limit of this plus this is the same as the limit of f of x, then I take the limit of what? G of x, the same thing. All right, so the limit of rational functions, the limit of rational functions are functions that can be expressed in the form of a ratio. Example, a on what? B, where b is not equal to what? 0. Why are we saying this? So this condition, we should note it. It is very important because when I have a fraction here and it happens that the denominator becomes 0, this is going to be difficult to do what? Define. So usually we say what is going to be undefined because as the values here, um, this one getting closer or it is approaching 0, this number becomes too large, all right, to define. If one is asked to find the limit of a rational function, there are two techniques to use. So the first one could be dividing out common what? Factors. And the second one is rationalization. Rationalization. So we have two factors, dividing out common factors and rationalization. All right. So let's take an example on the limit of rational functions. Now we have this, we are to solve this here, the limit of the function x squared plus x plus 6, all divided by x plus 3 as x approaches negative 3. Now, let's look at this. Can we easily or simply substitute negative 3 into this? Now, let's see if that will work for us. If we decide to substitute negative 3 here, the down becomes what? 0. All right. Then we put negative 3 here. We have negative 3 squared. This is going to give us 9 plus negative 3. So we get minus 3. So we're going to get 6 minus, we are going to get 9 here minus 3. So we get what? 6, right? We get 6. Then plus, you see that this is going to give us something that you are going to get undefined. So there's no need doing what? Substituting it straight. So we need to write it in a form that we can easily work with. Now, with this, you can see that this, the top one here, we can write it as this. So we can factorize that one out and factorize it easily. So that's the first rule, that the technique that we said we can divide through by common factors. So you can see that this, we have x minus 2 then x plus 3 common. This is x plus 3. This is x plus 3. So this is going to go out. Now we have the limit of x minus 2. As x approaches negative 3, you can easily substitute this. And nothing is going to happen to this. So our answer is what? Negative 5. Now we have the next one. Evaluate the limit of x squared minus 2x divided by x. All right. So realize that when we try to substitute this one straight into it, something will happen. We have 0 squared minus 0 divided by 0. This is going to be what? Indeterminate. Indeterminate. We have 0 divided by 0. So we can move on to work out this. Now, we can see that the top one here, we have x being common. So we can easily factor x out. When you factor x out, this is common to this, so you can cancel. This will go with this, right? Then easily we can substitute our value, and this is going to give us what? Negative 2, and this is what? Negative 5. So thank you for watching.